Legend says that anyone who disturbs the resting place of an Egyptian pharaoh is doomed by a deadly curse. But what if that very curse is the cure? In 1922, the world gasped as archaeologist Howard Carter unsealed Tutankhamun's tomb. Within months, Lord Carnarvon, the expedition's patron, was dead. Newspapers screamed mummy's curse, and the myth was born. Decades later, 10 of 12 researchers who opened King Casimir IV's crypt in Poland died soon after. What invisible killer lurked inside those royal coffins? It wasn't magic, it was microbiology. Meet Aspergillus flavus, a fungus capable of lying dormant for centuries, then bursting into deadly life when tomb dust is disturbed. A century after Carnarvon's death, Dr. Sherry Gow and her team at the University of Pennsylvania had a different idea. Don't fear the fungus, sequence it. We suspected the cursed fungus was producing unusual small molecules, nature's own chemistry set. Inside that vial, a cocktail of ribosomally synthesized and post-translationally modified peptides, RIPs for short. These are molecular origami masterpieces and potential drugs. The team uncovered 4 never-before-seen compounds. They named them asperigimycins after the fungus that forged them deep inside pharaonic tombs. Imagine 7 interlocking rings like Olympic rings on steroids. That complexity lets the molecule wedge into cancer cell machinery where simpler drugs can't reach. In Petri dish showdowns, to asperigimycins killed acute myeloid leukemia cells as effectively as gold standard chemo agents, but spared breast, liver, and lung cells. To supercharge the kill factor, Gow's group borrowed a page from beehives. Royal jelly lipids, yes. The stuff that nourishes queen bees can sneak drugs through oily cell. Attach the right lipid, and the compound slips past the cell wall like a Trojan horse. But once inside, asperigimycins hit a roadblock, endorsomal jail. Enter SLC46A3, a gene coding for a tiny transporter protein that pries open that jail. SLC46A3 is like an emergency exit. We mapped that pathway with CRISPR screens and suddenly response rates skyrocketed. Current chemo slashes through healthy marrow, causing hair loss, fatigue, and infection risk. Asperigimycins behave more like precision-guided arrows. If a future treatment can spare my healthy cells, sign me up yesterday. Penicillin, cyclosporine, statins. Our medicine cabinet is already half fungal, yet RIPs from fungi are a barely tapped goldmine. We've only scanned a handful of species. Hundreds could hide new asperigimycins, or something even better. Will every lab hit be a bedside miracle? No. Complex molecules are notoriously hard to scale up, and off-target effects may surface in animal studies. 7-ring peptides challenge synthetic chemists, but advances in enzymatic engineering mean we can teach bacteria or even plants to mass-produce them. 100 years ago, fear of a curse gripped the public. Today, we wield genome sequencers instead of amulets. The ancients left us art and architecture, but also microbes. Their so-called curse might one day save millions. So the next time you hear whispers about a mummy's curse, remember it could be tomorrow's medicine. Love stories where history and science collide? Hit subscribe, ring that bell, and share this video with the curious minds in your life. Because the past isn't dead, it's alive in every breakthrough. Enjoyed the video? Don't forget to subscribe to Dynamic Trends for more mind-blowing discoveries at the intersection of science, history, and innovation. Hit that like button, ring the bell so you never miss an update. And check out the link in the description for 10 awesome Amazon products related to today's topic, handpicked just for you.